Okay, welcome back. This is lesson 16, irrational numbers. Objective for today is to define irrational and real numbers. Okay, so we're going to talk about what irrational numbers are and what real numbers are. First, irrational numbers. Irrational numbers are numbers with the decimals that never stop and never repeat. Okay, irrational numbers can also be the square root of any counting number that isn't a perfect square. So, if we remember, first of all, let's do the first example. Decimals that never stop and never repeat. So like 1, 2, 3, 4, 5, and it just keeps on going in that pattern. Okay, the numbers never repeat themselves and it would never stop going. So it would go 1.2, 3, 4, 5, 6, 7, 8, 9, 10, just keep going and going and going. Okay? It can also be the square root of a counting number that's not a perfect square. So remember our perfect square numbers were 0 and 1 and 4 and so on and so forth. So like the square root of 2. I don't know what the square root of 2 is because I don't know what number times itself gives me 2. Okay? Or the square root of 5. I don't know what number times itself gives me 5. So those two numbers are irrational numbers. Okay? Real numbers are the set of all rational and irrational numbers. Okay? So if I could draw a box and say inside that box are real numbers, that box would have to include rational and irrational numbers. Okay? So real numbers are all rational numbers and irrational numbers. So all the kinds of numbers we've talked about so far. Alright, let's go on to some examples. Okay, example 1 is first, objective 2 is to approximate a square root. Okay, approximate means to give me an answer that's close or about. So example 1 says, which number is irrational? So A is the square root of 0, B is the square root of 4, C is the square root of 8, and D is the square root of 16. So which number is irrational? Well, I know what the square root of 0 is. Okay, the square root of 0 equals 0. Okay, so that is a rational number because I can tell what its square root is. Okay, the square root of 4 equals 2. I know that. Okay, so that is rational, not irrational. Okay, now look at C and D. Which of those two numbers do you know what the square root is? Okay, and we should say that D, we know that the square root of 16 equals 4. So it is rational. So that means the only number on here I don't know the square root to is C. That is irrational. Okay, the square root of 8. I don't know what times itself gives me 8. Okay? I'm not sure. So that means it's irrational. Now to approximate a square root. Okay? Let's approximate what the square root of 8 is. So think of the perfect squares that are around 8. Okay? Well, 4 is a perfect square. And I know the square root of 4 is 2. Okay? What number higher than 8 is a perfect square? Well, 9 is a perfect square, and it's right around 8. The square root of 9 is 3. Okay, 8 is between these two numbers right here. Okay, it's between the square root of 4 and the square root of 9. Okay, square root of 8 is in between there. Square root of 4 is 2, the square root of 9 is 3. So that means the square root of 8 has to be between 2 and 3. So all we have to ask ourselves is which of those two numbers is 8 closer to? Is it closer to 4 or is it closer to 9? Okay, we should know that 8 is closer to 9. So that means that the square root of 8 has to be pretty close to 3. Okay, it's got to be closer to 3 than to 2. But it can't be 3, so it's got to be a little less than 3. So think of your numbers in here that would be between 2 and 3, like 2.1, 2.2, 2.3, so on and so forth. Okay, a number around 3 that would be pretty close would be like, I don't know, 2.8. Sounds good. Okay, so the square root of 8 is probably equal to about 2.8. That's how we approximate a square root. Figure out what perfect squares it's in between. Okay, and then just figure out which one of those is closest to. Alright, let's do more examples. Okay, example 2 says to arrange these real numbers in order from least to greatest. Okay, so we've got 2, the square root of 5, 5 ninths, 0, 3, 1.2, and 1. Alright, so we need to get all of these numbers kind of in the same form. Okay, so let's convert anything that's not a decimal to a decimal. Okay, well 2, we know that's easy. 0 and 3 are easy. 1.2 is easy. 1 is easy. So all we need to do, we need to convert square root of 5 to a decimal and 5 ninths to a decimal. Okay, so let's convert the square root of 5 to decimal. Okay, again, the square root of 5, think about this. This is between, okay, it's between the square root of 4, which is what? The square root of 4 is 2. Then we would have the square root of 5 is in there. And then what's the perfect square number after 5? That would be 9. So the square root of 9 is 3. So the square root of 5 is between the square root of 4 and the square root of 3. Or sorry, between the square root of 4 and the square root of 9. So the square root of 5 has to be between 2 and 3. It's going to be some decimal in there. Okay? Well, 5 is a lot closer to 4 than to 9. So the square root of 5 should be closer to 2 than it is to 3. So I'm going to guess it's going to be about 2.2 or so. Okay? 5 ninths. Convert that to a decimal. We need to divide the top. Take it divided by the bottom. Well, 9 doesn't go into 5, so we put a 0 and a dot. 9 goes into 50. That's 4, or sorry, this right here is just having a mental mess up. It's 5 times. Okay, 9 goes into 55 times. 9 times 5 is 45. Then I subtract. 50 minus 45 is 5. Bring it down to 0. And look at this. We got 50 again. Okay? Well, 9 goes into 50 5 times again. That means this 5 is going to repeat itself. Okay, so it's 0.5 repeating. So now what I want to do is I'm going to take these numbers. Okay? And I'm going to convert, or write the numbers that I converted in. So 2 I left. The square root of 5 was about 2.2. 5 ninths was 0.5 repeating. Then we had 0, 3, 1.2, and 1. Okay, and I'm going to write up here, remember this was the square root of 5, and this was 5 ninths. Well, let's go ahead and put them in order. 0 is the lowest one. Next is 0.5 repeating. That was 5 ninths originally. So we'll put it in as its original number, 5 ninths. Next looks like it's going to be 1. Oops, sorry about that. Then after that, it's going to be 1.2. After that, it's going to be 2. Then 2.2 comes next, but that was originally written as the square root of 5. And then 3. So there's all our original numbers in order from least to greatest. Okay, so again, convert them all to decimals first, anything that's not a decimal form, then order them. Alright, let's go on to our last example. Okay, the last example, the area of this square is 2 centimeters squared. What's the length of each side? By the way, during this example, I'd just like to take a moment to say I'm sorry about my voice. I got a cold, so I should have said that at the beginning of the slide, but oh well, here we go. So remember, the area of a square was area equals side squared. Okay, well we know our area is 2 centimeters. Because the side is squared, that means the side times itself. We have to take the square root of 2 to give us what our side is. Okay, so now I got to think to myself, what times itself gives me 2? Well, I don't know that answer. So this right here, square root of 2, is a perfectly acceptable answer because you don't know. Okay? It says what's the length of each side? Each side is the square root of 2 centimeters. Now if it asked you to approximate, if it said approximate each side, then I'd want to know about what is the square root of 2. So remember, the square root of 2 would be here. Well, underneath that, the square root of 1, 1 is a perfect square number, and then 4 is a perfect square number. Square root of 1 is 1, and the square root of 4 is 2. So our answer has to be between 1 and 2. So I'd say about, I don't know, it's a little closer to 1, but not too much closer, so it'd be about 1.4. Okay, centimeters. Now the problem did not ask you to approximate it, so you don't have to, okay? This step over here that I did, that's only if it tells you to approximate the square root. Alright, otherwise this answer is just fine over here. Alright, happy homeworking.